All right, so just label your notes. We are moving on from section 5.1. So still, yes, believe it or not, that really is a 5.
Bless you.
5.1. More natural log derivatives. And like I said to you guys, I just have one example to give you, and that's it. So the example that I am going to give you is y is equal to x way that this is going to be a natural logarithm derivative, and you see a problem that doesn't have a natural log in it. So, remember your basic algebra properties that you learned years and years and years ago. What you do to one side of an equation, you must do to the other side of the equation. So keeping that in mind and looking at this y equals equation, if you were to find the derivative of this, what kinds of things are screaming to you right now?
Square root of the bottom.
You have a square root on the bottom. Means you have a half power to deal with. What else?
Chain.
You have a chain rule, and you have a quotient rule. So, and not only do you have a chain rule going on in this problem, you have the chain rule 2 times, essentially. The top, I guess, you could FOIL out and not have to use the chain rule. But this would be a very horrendous problem if you had to do the quotient rule with fractional exponents and the chain rule. So, in situations like this, in fact, what I would like you to do would probably be helpful is put a little note next to this problem and say that you would need the chain rule twice and the quotient rule. So avoid, if possible. Avoid this if possible.
By all means,
So
you
if it's-
could do that though, right?
You could. Have I tried it? No. It might be fun though. Do you want to do that?
Yeah.
I really don't want to either.
No.
I can try it.
So yes, you could. I haven't tried it yet, but yeah, you could get it to work out. I'm not sure how pretty your answer would be, but yes, it would work. Definitely would work. So my suggestion would be to, in a case like this, use the ln instead. Use the ln instead. So when I say that, when I say use the ln instead, what you need to do is take the natural log of both sides. Remember a minute ago what I said, what you do to one side, you do to the other side too? You just need to make sure that if you take the natural log of one side, you take the natural log of the other side as well. So, can I flip pages because I'm going to need to rewrite? Yes?
What is the other side?
The other side is, when I say the other side, you actually have to take the ln of y.
Okay.
Yep, so take the ln of y, then take the ln of the other side. Okay, so, can I flip?
Yes.
So where we're going to end up here is the ln of y. I have not taken the derivative yet. I am only rewriting right now, and I'm taking the as long as I do it to the ln of both sides, I am not creating anything that's not legal in math. So we have the ln of y is equal to the ln of, what is it, you guys? X minus 2 squared
X minus 2 squared
over the square root of what?
X squared plus 1.
X squared plus 1. All right. Okay. And now what we're going to do is take the derivative. So let's worry about the left side. I'll tell you what to do because that's the new stuff. Is you guys should be comfortable with the right side. It's the left side that's going to just add a little step to this. How do you take the ln of y? As simple as that seems, it's not as simple as it seems. So let's take the ln, take the derivative of the ln of x minus 2 squared over the square root of x squared plus 1. Before we can take the derivative of it though, we probably should do some rewriting using our properties of natural logs. So the right side of this is going to be the ln of. We have two things right here that are being divided. So when they are being divided, I have to subtract them. So I'm going to have the ln of x minus 2 squared minus the ln of the square root of x squared plus 1. How can I write this nicer? Instead of saying the square root of x squared plus 1, what does that really mean? 1/2. So I'm going to say this is the ln of x minus 2 squared minus the ln of x squared plus 1 to the 1/2 power. I have some powers out there right now. How do I get rid of the powers? Just move them to the front. So this actually means 2 the ln of x minus 2 squared. No. This seems delayed today. Okay. 2 ln of x minus 2 minus 1/2 ln of x squared plus 1. So far, so good? Yes. All right. And on the left-hand side, we still have the ln of y. So now let's talk about the derivative. What is the derivative of, I'm going to ignore this 2 out front, I'm going to ignore it for just a minute. What is the derivative of the ln of x minus 2? It is 1 over what? Over x minus 2. So we have this 2 here, so we have 2 times 1 over x minus 2.
Wait, why is it like that?
Because it's a thing in the book.
Why is it 1 over x minus 2?
Oh, it's a rule.
The rule is that you take the derivative whenever you have a natural log, it is the derivative on top over the function on the bottom. U prime over u. All right, minus, we have a 1/2. What about this ln of x squared plus 1? 2x over x squared plus 1. All right. What about the left side? The ln of y. No, that's what I thought. That's what I would think too. 1 over y. The derivative of y is 1. But the problem is that y is actually the ln of, that's not true. Y is x minus 2 squared over the square root of x squared plus 1. So you can't just say it is 1 over y, because it's not just y, it's all of this stuff instead. So, when you take the natural log of y, all you need to do is say that it is the derivative of y prime, over y. And you will see what this means in just a minute, but for right now, I need you just work with me here. We're going to have y prime over y. In other words, we're just applying that generic u prime over u rule to the y instead of to a u. And let's keep going with this thing right here. We have a 2 times 1 over x minus 2. That means 2 over x minus 2. Yes? And then we have a minus. And we have a 2 on the bottom and a 2 on the top. Those two can cancel out, leaving you with what? X over x squared plus 1. Okay? We have y prime over y. Alright, I need to flip pages again, so I'm going to need you to help me remember what this says. Y prime over y is equal to 2 over
X minus 2.
minus
X over x squared plus 1.
plus 1. Thank you. Alright, what are we going to do with this now?
Cross multiply.
Cross multiply. So we multiply 2 times x squared plus 1. So this is equal to 2 quantity x squared plus 1 minus, now we cross multiply this way, which is x times x minus 2. And then we divide all of that by the two denominators multiplied, which is x minus 2 times x squared plus 1. And on the left side, we still have the derivative of y over y. I'm going to take this a step further, try to simplify it a little bit. I'm going to distribute the 2 in, giving me 2x squared plus 2. And then I'm going to distribute that negative x in, giving me minus x squared plus 2x. All over x minus 2 times x squared plus 1. Yes?
So, why can't the 2x minus 2 just cancel out?
The 2x minus 2 is this x minus 2 and that x minus 2, because this does not have it. Remember, it's kind of like we have 3 sections of this problem. And this has come up a lot of times in the past. When you have 3 situations, when you're going to cancel something out, that thing that you're going to cancel out has to show up in all 3 pieces. Okay? All right. This then is equal to, we have a 2x squared minus a 1x squared. That gets you x squared plus a 2x plus 2. Still with me?
Yep.
Not back trouble.
No, just.
Okay, I thought you said, okay. All over x minus 2 times x squared plus 1. We still have y prime over y. Now, remember our job here is to find the derivative of y. And the left-hand side has the derivative of y in it. But the derivative of y is being multiplied, or excuse me, is being divided by y. So if I want to get rid of that divide by y, what do I need to do?
Multiply by
You
y.
need to multiply by y. So you multiply this side by y, the y's cancel out. But if I multiply the left side by y, what must I do to the right side?
Multiply by y.
So you have to multiply this entire thing, this entire right side, by y. What's y? Well, first of all, up until now, nothing is really new. All of this stuff is stuff that you guys have been doing for a couple days now anyway. This is new. Multiplying by y is new. What is y? Where did we get y?
The very beginning.
The very beginning. So I need to go back to the original problem where we said that y was x minus 2 squared over the square root of x squared plus 1. And I've already forgotten what that said. So when I go back, I need you guys to help me fill that in. So I have the derivative of y is equal to x squared plus 2x plus 2 all over x minus 2 times x squared plus 1 times y. And y is
X minus 2 squared.
x minus 2 squared over
Square root of x squared plus 1.
square root of x squared plus 1. Okay, so we have this entire top that is being multiplied by this top. And then we have this entire bottom that is being multiplied by this bottom. So do we have anything in this problem that we can cancel out?
X minus 2.
Yeah, we have an x minus 2 right here that will cancel out with one of the x minus 2's in the top. So I'm going to get rid of this power of 2 and make it a power of 1 instead. Okay? And now you just need to write the leftovers down. But I want you to notice too that in the denominator we have an x squared plus 1, which is to a power of 1, and we are multiplying that by an x squared plus 1 that is actually to the power of 1/2. So if you have a power of 1 multiplied by a power of 1/2, what happens to the exponent? X to the 3/2 is going to be the quantity to the 3/2 power. So you have to add the 1 and the 1/2, giving you 1/2, which is the same thing as 3/2. All right, so new page. We have x squared plus 2x plus 2 multiplied by, is it x minus 2, you guys?
Yeah.
X minus 2, and then on the bottom, when you multiply those two denominators, we talked about how it was going to give you a total of a 3/2 power. So we had x squared plus 1 to the power of 3 over 2. That's it?
What?
Do you want me to?
No.
Because we could probably FOIL multiply the top.
I think we're doing
This is the derivative. So one new step. The one new step was to multiply your derivative by y, and then simplify it as much as you
There's
can.
no shortcut.
There's
There's no shortcuts. I feel like there is, but they look so similar.